Okay, I want to demonstrate how you can graph a polynomial function on the graphing calculator and identify the relative extrema. And in a later video, I will show you how you can graph the polynomial functions by hand, which is really the skill that I want you to have as well. So I have entered this polynomial negative 2x cubed minus 10x squared plus 6x minus 9 in my equation editor, and I did that by pressing the y equals key. Pay particular attention that you use the correct negative sign to denote subtraction as well as a negative sign on a number. Because the negative 2 is a negative coefficient, I would want to use the negative sign to denote that. But when it's an operator between two expressions, I would use the subtraction sign. And I'm going to then graph that function. Now my graph, if I choose the zoom, my graph is probably in this standard window, which is, let me show you that for a minute. Yes, so it was in the standard window. The standard window is from negative 10 to 10 in the x direction and y direction. The problem with these polynomial functions is that they can get quite large or small values pretty quickly, and we will need to readjust our viewing window. To do that, I will suggest that you press second and graph so that we can go to the table. And what I want to look at are values with the graph. Like, for instance, I know that this graph was an odd degree function with a negative leading coefficient, so I know that it's going to go up to the left and down to the right. And I can see that here, right? As I get more negative, the y values are getting much more positive. So I don't really care about that. What I need to zero in on is where the changes, the turning points are occurring. So I see that there are some positive values and then it goes negative. And then it's more and more negative. And so I need to zero in on this action here. So if I set my maximum y value to, let's say, 50 or 100, it doesn't really matter. And then we know it goes really, really negative, so we'll say from negative 100 to 100 would probably be a good estimation of that. And our x values that we need are between negative 10 and 10. We can actually see those changes. So I'm going to go to my window settings. I'm going to leave negative 10 to 10 this way it is. But now I'm going to put in negative 100 and 100. Now if you were plotting this by hand and you had to count up to 100, you probably would not count by ones. A good scale might be to use a 10, right, to count by 10, 20, and so on. And I don't ever change those other values, so you don't need to worry about that. And now let's go back to graph and see if we can get the picture a little bit clearer. Okay, good. So now we see that there are two turning points, and I can get those estimates. Notice that the one on the left is a minimum, and then I have a maximum. And so what I would have to do to obtain those is I'm going to press second and calc, or second and trace to get to the calc menu. If we want to do our minimum point first, I'm going to press 3. And now I need to be on the left side of that minimum point. So again, think about a vertical line through that point, be on the left of it, and it doesn't matter how far left you go. And I'm going to press enter. And now I need to be on the right side of that. So I'm moving my cursor somewhere over to the right side, but not over to the next hill, right? I need to just stay around this particular valley point that I'm looking at. I'm going to press enter. And now my guess, I'm going to be in between those two markers and press enter. And so it's telling me here that a minimum point that I have is at, what is that, negative 3.61, comma, negative 66.89. Now to obtain my relative max, I'm going to clear this out and I'm going to press second trace and choose now option 4, which is a maximum. And notice that it says left bound, so I need to be somewhere on the left side of that peak. So I'm just going to move closer to it. I'm already on the left side of it, so I'm going to move to the little bit closer and press enter. And now my right bound, I'm going to have to go over the hill and get to the right side and press enter. And now my guess, move back between those two markers and press enter. And so it tells me that my relative max is 0.28 if I round to 2 decimal places. And negative 8.15. Now, while we're here, we can identify any zeros or intercepts. So if I wanted to find, let me clear that, the y-intercept is when x is 0. A real easy way to do that is press the trace key. And I'm just going to type in 0, and that takes me to the x value of 0 and enter. So I see that my y-intercept is 0, negative 9. I could have also plugged 0 into the function, right? That's pretty easy to do. Now, I do see a 0 here, and to find that 0, I probably could not factor that. I don't think it factors just from looking at it, so I would have to find another way, and I can do that on the calculator. To find that 0, I'm going to clear this operation and press second trace, and you'll see that now I have this option for 0, and so that helps you find the x-intercepts. And then it's the same series of questions. I need to do a left bound and a right bound and a guess. So I've got to go to the left of that x-intercept. So again, think about a vertical line through that. Go to the left side of it. Press enter. Now go to the right side of it and press enter. And now move between those markers and press enter. And so this is telling me that my x-intercept is negative 5.670. Now 1e to the negative 11 is scientific notation that stands for 1 times 10 to the negative 11, which is a 0.000. In other words, there's 10 zeros before that 1, which is basically 0. And just while we're at it, the domain and range, remember this is an odd degree polynomial function, so the domain and range of that would be negative infinity to infinity. So hopefully that helps let you see how you can use a graphing calculator to get those values that you need.